Okay, so I want to give a practical talk on page load performance. Probably many of you have seen these talks where you talk like, oh, this is how we start everything, and in the end it's perfect. Real projects are never perfect because you have to work on the stuff you already have. You have some dependencies, you have some weird font libraries or whatever, and you have to work with what you have. Also, you can't optimize perfectly, but you have to find a good middle ground. And I'll try to talk about that. And in the end, you'll see that I'm trying to get perfect again, and it'll be quite nerdy. The whole thing started 2014. 2014, I built this website with great technologies like jQuery. And at the time, it was a really cool website. The whole thing with this triangle, all rendered in CSS, was really like fancy at the time and really cool. And since then, people still like the design, and I didn't like the tech anymore. And also the client didn't like the tech anymore because the backend looked like this, and there were we had some performance issues based on old technologies and things like that. Also, there was in parallel a WordPress block, and the performance here was really bad. You can see loading, you can see a bit loading almost 20 megabytes of data for opening the homepage of the blog. So that was all a bit of pain in the ass. So the idea was to make a full technology update. So we tried to take the code which still works and make it modern and integrate it in a new CMS system. The final CMS looks like this. So the idea is that the CMS looks like the website, and you can just inline write all the content you want and have everything like easy to understand instead of this thing here. Yes, so this is where we started. We have two projects which are using different code written in 2014. It's still quite okay, but I want to have it better. Let's see if we can go there. The first one was I just ported the existing code to the new CMS system. I took all the same JavaScript, all the same CSS, all the same HTML, and just wrapped it in a new system. The first thing which made problems was the sprite maps. I'm not sure if all of you know that. The idea was that if you have many small icons, they take quite a long time to load, because at the time, a browser did only load 4 resources at the same time from one domain. And so instead you make one big picture where all the small icons are in it, and then you just always use parts of that. That was a best practice kind of micro optimization at the time. It worked with Compass, so we have a Ruby dependency on it, and it was quite a pain in the ass to use this technology. So we threw it away, and we now just include the icons normally. Yeah. Simple is never simple. You think like, oh, I just take the technologies, and then it takes you 2 hours to just be able to start it up again on your development machine. Also, all optimizations are trade-offs. Things like with the sprite map right now, it optimized the speed, but it made development more complex. And you should always try to find a trade-off that makes sense, so you don't optimize everything. So I said, okay, we don't need sprite maps anymore. Let's just include it as normal icons, and the code became easier. The biggest thing on a website are normally the images. They take up more than 50% of the kilobytes normally, and so optimizing images is very important. In this original version, responsive images did not exist yet. So there were some JavaScript libraries who tried to do that in browsers by measuring the size of the browser, and then with JavaScript loading images. So I got rid of all of that and used responsive images. The basic idea is your website is not only looked at in one browser, but we have many different browser sizes, many different devices, and you want to load for each device the image which is crystal sharp, but at the same time not too big because it's wasted a bandwidth. So there are two reasons for responsive images. There's art direction, so you can show different images for different screen sizes or different layouts. I don't care about that right now. This would be the idea here. There's a picture element, and then there's the performance thing where we have the exactly same image, but in multiple different versions. This is defined with sizes and source set. In source set, you have two options. Always use this one here. So what this is doing is that I'm here defining a fallback image. This is the one, or not, yeah, this is like the fallback image. And then I'm defining a source set. And this means I'm defining, hey, this lighthouse image exists with 100 pixel width, with 200 pixels, 400, 800, 1000, 1400, 1800. So if I'm on a really big screen, it will take the big image. If I'm on a very small screen, it will take the small image. And this will be like 5% of this big screen. So it's fast on mobile because it only loads the small thing. The second part, which I mentioned here at the top, is the sizes. This is the most typical use case where you write 50 view widths or 100. The view width means the browser width in CSS pixels. So ignore Retina and everything. The browser takes care of that. Just normal CSS pixels. And here it would take half of the browser width as picture size. And you always need to do that in CSS and here as well with the sizes attribute, because the browser fetches this and does not understand yet the CSS and still loads already the correct image. And then depending on your on your device, it automatically picks up the right image. You don't really have to care about the other thing. Just give it a lot of different size options, a lot of different images, and define your sizes. The easiest one is to just define sizes 100%. You can't be really wrong here. But on big screens, you load some unnecessary images. So if you use some libraries who automatically give you responsive images, they normally use 100% view width, which is kind of okay, but not perfect. If you write it manually, and you just need to write it manually once, it's even better. So this can grow quite large, but you just do it once. So you see here I have an image. Oops, here I have an image, and it just defined here with 3 breakpoints what size it will have, and then I give loads of image options, and the browser figures out which one to take. That's the idea about responsive images. The problem here still is if you have a very long page and you have many pictures, maybe like full width pictures which look cool, that they will all be loaded when you first open the page. So the next thing you want to optimize is to only show the content which is shown right now and everything else later. This is the concept of lazy sizes. So let me just jump forward here. So this is an example how a page would load. In the beginning, you see it just loaded a very bad image. It loads the good one now. And if I scroll down, as soon as I scroll in the viewport, it will load the high resolution image. And so on this page, I have 10 images, but when I first open it, it only loads 1 image, and the others come later. There's a really good library for that, which is called lazy sizes. Basically, what you do is you just define, instead of setting the sizes, source set, sizes and source set directly, you add this data minus before, and then there's a JavaScript file, lazy sizes.js, which looks for all images which are called lazy load, checks if it's already in cache. If it's in a cache, it puts the right image there. If not, it will load that image or only when you come near the viewport. And this is, yeah, you don't need to care about much of that anymore. So this is the result we get, and I'm on purpose not showing you too much code because it's really easy if you read the README on GitHub to understand how it looks. I want to focus a bit more on how to do it. So now this is the time where we have a decent website. We have some CSS, some JavaScript, it loads the page, we have responsive images and lazy loading, which will already give you the biggest amount of improvement. And now we want to further optimize it. This is where we start to open the developer tools, and there's a network tab, and in the network tab you want to say disable cache, and when you have the cache disabled, you'll always see how it would first load the page. So as always, the first thing which loads will be the HTML page. So this is on my local development machine, so that's why it's a bit slow. That's okay, because it's just for testing. You see the first thing which loads is my HTML file, and then it loads a cookie consent CSS, then it loads a web font CSS, then it loads my actual app CSS, so this is where all my styles are. Then it loads lazy sizes, which we talked about already. Then it starts to load some images, and then there's some further stuff. Probably interesting, we're using web fonts to have custom fonts on the website. So normally the browser does not render any text content until the font is loaded. So you'll see just white till the font loads. And you notice here at the top, this is where we first start to load our font, which is quite late because it's one of the most important things. If you open a website, the content should be visible as soon as possible. So what I would like to do is to get the font loading more up here. There's some small side notes. As I said, this is local development, and also if you work locally, if you load a page, the timing will change every time. Every time you execute on your local system, something is slower or faster. Don't look at the actual numbers, just look at the relationship, which loads after what, and how are things progressing, and not so much on the speed of an individual thing. Also, if you just open it like this, the downloading is really fast. If I'm opening in my local browser image, which is on my local machine, downloading is really fast. So you see, actually, these are huge images. No, not, where is it? These are huge images, 1 megabyte, but it's tiny here. And we'll see how to fix that a bit later. The first thing which I would recommend you to start development is, instead of including a CSS resource, just inline all your CSS in HTML. So, of course, you will create a app CSS file, but then instead of referencing it with link, just include all of that in the HTML. We'll talk a bit more about that later, but now that would be the first step to do. And now we get a bit of different perspective. This one is again our weird font loading CSS, which we can't get rid of. But we start by loading the HTML, and then it already starts loading the pictures. Then it loads the JavaScript, and so on. Our font is still at the bottom. So our ideal graph, how would that look? This is actually a question you should ask yourself. And for most websites, the ideal graph would be first load the HTML, then load the CSS you need, because without CSS, nothing can really render. This is why I'm right now just inlining all the CSS, so this doesn't have an effect on loading. And then probably the first thing you want to load is fonts, if you have fonts. And then you want to load the most important images, depending on how this screen looks, the most important images. So how to fix the font loading? there are a few things which you should consider. Since a while, there's a WAF2, which is half the size of the old font. So if your old projects create a new version of your font which includes WAF2, it's way smaller. And here you can see there's a property called font display. Font display defines how a browser should react if you load a website and the font is not yet loaded. So if I open the website the first time, I'm using a web font, it's not yet loaded. The typical behavior would be that it's just white, which makes it feels like it's very slow because the thing I'm actually caring about, the text is not there. So there's an option which is called swap, and it's in most cases the recommended version. What swap does is it takes a system font until the real web font is loaded. So this causes a relayout. So when you load the web font, things move a bit, but very fast you already have content to read. And so if the person opens the website, they instantly see text, which is really great. And then in HTML at the top, you can define something called preload. And with preload, you tell the browser what it should load, even if it doesn't yet know that it needs it. So in my example, the browser typically opens the website. In the website, it includes the font, which is not self-hosted, but it's hosted on a CDN. So I can directly link to that font. And so I'm downloading a CSS file, and that CSS file, it finds that it needs a font, and then it loads the font. So this is like HTML, CSS, font. And I want to get the CSS in the middle way. So I'm defining preload. And preload means when it's reading one of the first bytes of HTML, it already knows, oh, I need to load that font. So this means that actually it moves my font to the top. And here I'm optimizing for the typical use case. So you have seen, actually there are many different font versions. I care about the one which will happen most of the time. So Chrome or Firefox or modern browsers. In modern browsers, it supports WAF2. So I'm preloading WAF2, and you see it's the second thing already. And yeah, another thing is you can put your JavaScript in the header, but define defer. And that means it will already start loading the JavaScript, but it executes it only after it finished creating the DOM. So yeah, also I removed some extra resources, and this is how it looks now. So you can see the big things are the HTML at the top, which is so slow, and then we have many resources. I talked about that it doesn't really show how long something will download when I open it on the web. And to fix that, there's something called network throttling. So what you can do is here at the top, there's network throttling. If you open it, you can define how fast it should download assets or fake to download assets. So I'm changing it to 3G, and then the website loads as if I would be on 3G. And now it gives me a better understanding of how something would load. I'm right now only showing you the desktop version. Of course, the mobile is also important, but on a desktop, it's not really realistic that you only have 3G, but it's still great because it gives you enough time to look at how things are rendered and how things are reacting. Also, my computer is slow because of the screen recording and everything, so it's really easy to see when I first load a page. You see it loads the structure, then it loads the fonts, and then it starts to load the images, and they take quite a long time because they're so big. So this is, let's do it again. No. Yeah, so it loads, it first has the structure, then it puts the text in, and then it starts to put the images in. So this is now with 3G selected, and you can see downloading these images, these two big images, takes up most of the time. So now this is something we can optimize. We talked about lazy loading of images. And if you just consider the page load time, the full page load time, lazy loading actually makes it worse. Because if I would open the page like this, it will load and it just loads the resources. But if I use lazy load, it will first load some small version of the image, which is some bandwidth. Then it needs to use the JavaScript to figure out what images to really load, and then it loads the real images. So the load time is longer, but the perceived load time is better. So if you take a look at how it will look now, I already see all the structure. And this is just like really bad images, and they will now appear, the good ones. But for this long time, I already saw there's some pictures. And so I already can understand what the web page is showing me, and it feels way faster. So this is what we see here now. We're loading some really tiny pictures here at the top. You see they have less than 10 kilobytes. And then as the last element of all, we're loading the big pictures. So here, the user can already see everything. And this is just till they can see the high resolution images. That feels way better. So the perceived loading time is way better. And the content is, I have no idea what I typed here. Also, the content is already faster to see, so people can actually start reading text till the high resolution images are loaded. But the page load takes longer, and also the biggest resources are loaded last. So it's not really optimal if you know this asset will take the longest time to download, and then you wait the longest till you start downloading it. That's not really great. So I wasn't happy with that. So I had another idea. What I actually want to have is that very fast there's some kind of unsharp picture, so you can already understand how the website looks, and then the high resolution images is loaded. But I want to load the high resolution image without JavaScript, so I cannot use lazy sizes. So what I was trying here is I'm using a normal responsive image, so with source set and sizes. So the browser sees it, understands it, and loads the correct image. And I'm using a background image on this image itself to show something fast. And this looked like this. And I wasn't really happy because what happened now is that when I first open the website, you see a bit longer this gray background, and so it flickers. It first loads, and the reason for that is it first loads the HTML, the CSS, and then the browser has to understand the CSS, and only after it understood the CSS, it can start to download the background image. And this is why this feels worse than the lazy sizes. And if you remember, we talked about something before, how we could tell the browser that it actually needs this background image really fast. There's preload again. So I'm defining at the top really fast, hey, please download these two background images. I'll need them. And oops. So what it does, it loads the HTML. It instantly starts to download the background images. And then here later, but not as late as before, it starts to download the big images. And this, why doesn't it start? Yeah. And so this now looks like this. The website appears, the background is really fast here, and then it takes a long time to download the big resources. But it feels like the final website already. Yeah, so these were some micro optimizations, but micro optimizations which made my day. I enjoyed doing that. There were some other micro optimizations. The old website used jQuery, and it used it almost only for the date picker, which was from jQuery UI, date picker. And there's a reason why you haven't seen the date picker, because it's, I can show you. It's only used if you click a button and then there's this date picker. So you could really easily either change it to a different library or load it later. And I thought maybe for the browser to understand this JavaScript takes a bit of time, and to download it as well. I tried to remove all the jQuery code without having a replacement, just like my local development. I removed it, and it did not change a thing in performance. So I figured out, oh, instead of wasting my time, I just keep it in. Not a perfect world, but it's fine. There's another thing. There is a separate gallery page which has quite a lot of JavaScript for this gallery logic. Actually, removing that made a difference. So this is a separate module. And so this will only be loaded if I'm on a page where a gallery exists. Inline CSS images. I did something which you probably didn't notice so far. But if you see how this page loads, this one here is an image, but it's an SVG, and so I could inline that SVG in the HTML, and that's why it's here so fast. Because this is actually one of the most important content on this page here. The goal of this page is that the user decides, do you want to know more about the restaurant or about the hotel? So being able to read this here is quite important. And so you can inline SVG. SVGs are normally super small, so inlining them in HTML is okay. And then it's here really fast. You could also use sprite maps. I did not do that. I didn't feel like that's a great improvement anymore. Especially with now HTTP2, it will not be important anymore. Also, you remember at the beginning, I told you that I just inline all the CSS. And the reason for that was that later I can create, there's something, I'm not sure if you know it, there's something called critical path CSS. So the idea is you have a tool, normally in the build step, which figures out what CSS is used when you first open a page, and it creates just a separate small version of your CSS, which is the thing you need really, really fast. And then all the CSS which you'll see only after scrolling will be included later. So the idea is if you have a big CSS file, you can split it up in two files. The one which is really important, you'll inline that, and the other one can be loaded later. In my case, the CSS was so small that creating a critical path CSS did not make a difference. So I kept it simple and did not do that because micro optimizations always make it harder for you to later maintain that. If you do a lot of crazy micro optimizations, it's great, and then in a year you have to change something and you're like, what's all this tooling? Yeah, so it will never be perfect, note to myself. There's still way for improvement, but it's really cool. So in the optimal solution, the page loads in less than a second, and the even more important thing here is that already here the website feels like it's finished, so way earlier than the full load. Because you can see already the HTML and you can see all the structure, and then it just loads some high quality stuff, which I don't need so much, so importantly. Yeah, obviously there's one thing which could further be improved, the loading of the initial HTML. If you have those as a static resource, or if you use a CDN, this can also be optimized. Yeah, and so this is how it looks finally. You see, I had the browser developer tools open. So this is an uncached loading. Whoops. And it's here really fast. Also, just as a side note, do not only optimize the home page. I did optimize the other pages as well. It's just too much for the talk here. Try to focus on the pages which are used most often. The home page is one of those, but there are others. Yeah, I hope you liked my thoughts, especially on this image loading things. If you have questions, you can contact me, or of course, ask questions now. Thanks.